here's our video on permutations and combinations. So permutation combinations, they're just a way that we can order items or things in certain combinations or certain permutations. Let's say we had certain squares. We had, let's put a couple, say we had a blue square, we had a green square, and we had a red square. Stuff like that. How many combinations can I make? Well, if I said a blue square and a green square and a red square, that's the only combination I can make. Because a red, green, and blue is the same thing. With combinations, the order doesn't matter. So if you're getting a blue, green, and red square, it's the same as getting a red, green, and blue square. It's the same thing. Order does not matter. So again, with combinations, order does not matter. Permutations, order does matter. Bring that matter in there, you see it? There we go. But let's keep this blue, green, and red square. And let's say I just want to get two at a time. So I can get a blue and a green. I can get a blue and a red. I can't get a green and a blue because that's the same thing with the combination. But I can get a green and a red. So how many combinations can I have? Am I missing one? There's only 3 possible combinations. Again, red-green is the same as green-red. Red-blue is the same as blue-red. So there's only 3 combinations. Permutations are different. So if I had a permutation here, order does matter. So I can have a blue-green, I can have a blue-red, but then I can also have a green-blue and a green-red, and I can also have a red-blue and a red-green. That's a permutation. So again, with combinations, there was only 3 possibilities, getting 2 at a time. Permutation, there was 6. Because in the permutation, I wanted blue first, but over here I wanted green first. So order does matter in a permutation, does not matter in a combination. The best way to remember it is at a fast food restaurant. So here you are at a restaurant and you want to order burgers, fries, and a shake. But then you turn around and say, no, you know what? I'll just have a shake, fries, and a burger instead. Well, that's the same thing. The person would look at you strange. So if the order does not matter, in this case, the order does not matter how you order it, right? It's a combination. And there's only one combination, burgers, fries, and a shake. It wouldn't make sense for this to be a permutation. Now, one permutation that's actually, one combination that's actually a permutation is your lock. You're going to get a lock in high school. And they always say, what's your combination? Don't forget your combination when you go to high school. So let's say you had these numbers. You had to do 12, 15, and let's say 8. That was your combination. Well, actually, it's a permutation because order matters. So 12, 15, 18 is not the same as saying 8, 15, 12. In a combination, remember, you can switch the orders. Can switch the orders. Orders don't matter. Orders don't matter in a combination. But in a permutation, what your lock is, it matters. 12 has to come first. So this is actually a permutation. So you would say, oh, I forgot my permutation, not your combination. So let me review that again. If this was a combination, then 8 could come first. Or 12 can come in the middle, or 12 can be last, if it's a combination. But it's not. It's a permutation. 12 has to come first based on this sequence. It has to come first. Order matters. It's a permutation. Okay, so let me review again. If you could change the order and it doesn't matter, it's a combination. If you can't change the order, it's a permutation. Try to remember that. So let's say we had a blue, a green, a yellow, and red ball or whatever. Let's just say a square. and I wanted to pick 2 at a time. We can make our combinations. We can have a blue and a green. We can have a blue and a yellow. We can have a blue and a red. Right? We can have a green and a yellow. We can have a green and a red. And then we can have a yellow and a red. And that's it. Right? We can't have a green and a blue in a combination because that's the same thing. So if I was going to take 2 at a time, this would be the amount of combinations I can have. Blue has 3, green has 2, yellow has 1, and we won't have any red because red's already involved. Can't say red yellow, it's the same as yellow red. We can't say red green, it's the same as green red, same thing. So there's only 6 combinations if we take 2 at a time with that. Now let's look at it as a permutation. So permutation, we can have blue and green because that's what we want, but we can also have green and blue. So you can have blue green, blue yellow, blue red, and then you can have green blue like we said. You can have green yellow, green red. And what others are missing? Permutation now. You make 2 more rows. Well, you can have a yellow blue, a yellow green, and a yellow red. And the last one, you can have a red blue, a red yellow, a red green. So you can see with the permutation, there's a lot more. There's 12. 12 permutations, but only 6 combinations. Now there's a formula for this, so you don't have to make all the combinations, all the permutations. But before we do that, I need to introduce you to this thing. It's kind of weird. That symbol is a factorial. So this is a factorial symbol. And it's pretty easy. So let's say I gave you, let's do it over here. We said 6 factorial. Well, 6 factorial, all it is just 6 times 5 times 4 times 3 times 2. And times 1. But you don't have to put the 1 because anything times 1 is the same thing. So if you multiply all this, that will be 6 factorial. What do you think 6 factorial is? Well, if you just multiplied all this, 6 factorial, I put it over here, is 720. Because it's 6 times 5 times 4 times 3 times 2 times 1. So again, this is a factorial sign. What is 4 factorial? Again, it's going to be 4 times 3 times 2. So 4 factorial is 24. Now, what about this? See if you can do this one. What if I gave you 6 factorial over 2 factorial? What would that be? Well, we already said that 6 factorial is 720, and 2 factorial is 2. So what is the answer? It'll be 360. So what if I gave you 5 factorial divided by 4 factorial? You can also list them up here. You can say 5 times 4 times 3 times 2. And here will be 4 times 3 times 2. And you can cross out what they share. So you're left with just 5. So you know 5 factorial is 120 if you multiplied all that together. And 4 factorial is 24. And you get an answer of 5. Let's do one more. What if I gave you 12 factorial over 8 factorial? So again, instead of multiplying them all, you can just write them out. 12 times 11 times 10 times 9. And I'm going to stop there. I wonder why. Because 8 times 7 times 6, all that gets canceled. Because up here you're going to have 8 times 7 times 6 times 5 and so on. So you're just left with 12 times 11 times 10 times 9. Right? And that's going to give you what, 11,860. Big number. Okay, we're going to look more at permutations and combinations in the next video. Great job.